Hi there, my name is Liam, and today I'll be walking through my NSF GRFP proposal to monitor phytoplankton mean bulk population body size change in the Santa Monica Bay. Let's jump in. Picture this, the ocean, filled with bounty and life, an azul trove of biodiversity and productivity. And look, there you are, hanging out in the near coastal waters of the great city of Angels, Los Angeles, California. More specifically, and for future reference, you're here, floating around and photosynthesizing like the dapper little dinoflagellate you are in the beautiful Santa Monica Bay. It's awesome here. The natural upwelling against the continent means your water, although a little acidic now and then, is rich with nutrients, which rocks. However, life isn't always normal here in the Santa Monica Bay. Home to millions of humans, dotted with agricultural centers, water treatment facilities, and other runoff deposit sources, the Santa Monica Bay, like most of our planet's environment and the climate itself, is being dramatically affected by human activity. Things like pesticides, fertilizers, industrial chemicals, and others can enter our waterways and wind up bringing excess chemical nutrients right to your hungry little flagellum. But there's a chance that it could have irreversible consequences. Recent studies have shown that excess nutrient saturation can lead to extreme phytoplankton blooming events and eutrophication. Other papers have examined the relationship between organism size and nutrient concentration and found larger critters tend to have a competitive advantage and favor more nutrient-dense ecosystems. My proposal seeks to explore this concept and track how the mean size of primary producing organisms in the Santa Monica Bay will change as nutrient concentrations stay oversaturated. Based on referenced papers, my hypothesis is that the mean size will increase. So perhaps your future descendants are going to be way bigger than you. But how will I do this? I'll use my AOS department's very own research vessel, the AOS Zodiac. While you and all your primary producing pals soak up those excess nutrients and possibly change based on the environment, I'll be taking the Zodiac out with plankton nets to gather up samples from preset locations for size analysis under a microscope. I'll be gathering tons of data over a 5-year period in order to track and observe how populations shift, as well as using nutrient concentration remote sensing to capture how my measurements correlate with the ambient conditions. Once I take you and the other primary producing organisms back to the lab, I'll measure them and build a cohesive data set, keeping track of when, where, and what the organism is and where it came from. The ramifications of this research are tremendous, as it could offer further insight into how humans impact oceanic systems. Primary producers serve as the basis of our entire global food web. Any change to the organisms that fulfill this critical ecological niche could have lasting ramifications across the entire global ecosystem. That's why studying these types of impacts is so vitally important. Additionally, this type of research can be a significant indicator for future policy design. When scientists and lawmakers work together effectively and efficiently, they can find the best approaches to making sure we maintain a healthy and functioning system. As someone personally very interested in environmental law, I think cooperative collaboration across sectors is vital for making sure we maintain a healthy world. And hey, picture it. Without constant anthropogenic influence, your happy little dinoflagellate existence can continue, soaking up all of the sun you need as you produce away happily ever after. Or, until you inevitably are consumed by a hydrotrophic organism. Thank you for watching, and have a good one.